Oh my god, stream information, day 5. Done. Alright. Alright, what do we got? Disable preview. File. Run. Okay, so this is what we got. Alright, so this jittering needs to go away. So let's figure that out. We can't turn on bilinear. We have to do our own blending, pretty much. Here. Yeah, that to do. Do we have any other to-dos? No, that's the only one that's here. Well, okay, let's do that then. Okay, well, first of all, I want to move that first rectangle to the left edge of the screen. Which means what? We know our half span is 10 and the dimension is 5, so well, minus 10 would be the left edge, except that we need to go forward by 2.5, so minus 10 plus 2.5. Minus 10.0, just in case. Okay, yeah, so that's at the left edge. Okay, now I want to go to render doc, which I don't have open. Load last settings, launch, capture, texture viewer, yeah, history. Okay. I just want to look at the input first. Input. Position, okay, let's, alright, so 12.5, 18, 285, okay, what do these numbers mean? So that's the position in pixels, presumably, right? Yeah, that looks about right. What is the address? Okay, so position is presumably pixel position, by the looks of it. Hello. Can we? No, we have to do it like here. Yeah. Okay. Yeah, so it's pixel position. UV. Well, UV looks like it's that 0 to 1 normalized UV. Color is just, yeah, we're just passing in all ones here. Okay. Can we go to like right to the edge? Look at the input. Yeah, 0.5. So pixel center is at 0.5 in DirectX. So 0.5. UV is, well, not 0 actually, but yeah, kind of close. Close enough. Yeah. Okay, well. Okay, so we're just using a sampler. So okay, so all we have here is a sampler. We give it the UV, and it gives us back a color. Alright, let's go to the other edge, like here. Really? Can I? Yeah, I can zoom in here, can I? Okay. Debug. Input. Okay, 475 is the X, and this is almost 1. Let's see what we got to work with. File, new, sure. Oh my god. Okay, that's better. Is this on an M? Alright. So texels are much larger. Where is the rectangle? Where is the rectangle? Rectangle select, crop, warp. Can we draw a rectangle? A line, at least? No. A grid, like a... So what tools do we have? Fuzzy select, crop, unify transform, warp transform, bucket fill, paintbrush, eraser, clone, smudge, path, text, color picker, zoom. Interesting. I mean, we do have layers here. It's just what I kind of want. Tools. What do paths do? Ah, well, that's cool. Not what I need though. Okay, let's just go to Excalibur, I suppose. Oh, we have some rectangles here already. But how do you move around here with H? Hand. H for hand. Okay, we have very large texels. Well, can I actually like copy it? Yeah, I can. Okay, so we have very large texels and very small pixels by comparison. Actually, I kind of want this thing. Right. Okay. So if these are the pixels and these are the pixels, can we fill it? We can fill it. Okay. There we go. So if this texel is red and this texel is blue, and we've got these pixels sampling from them, and they're aligned, then we don't have any problems. We do have problems, however, when they're not aligned. So that, hold on. That is one case where they're not aligned, and this is another case. Okay, so in either of these cases there is one pixel that kind of straddles the texels, and that one pixel needs to be blended somehow. But only the one. If we turn on bilinear filtering, all of them will be blended. And it will be not what we're looking for. The pixel shader gives us the coordinates of each pixel. So that's something. But what I kind of want is I want to be able to detect this case, where the nearest pixel might be red, but like actually, again, what do we have? We have a pixel coordinate in the UV. So for this pixel, the pixel coordinate would be, let's say, pixel center. Some kind of like 4.5. And the texel coordinate is just how far along, like if this is the beginning of the texture, just how far along the texture you are. Well, how far along the texture you are, that tells you nothing about where the edge between the texels is, though. So that's a problem. What do we do? What do we need extra information that we're not getting from the? Let's close that. That we're not getting from the shader. Pixel history, debugging pixel. Yeah, that's all we're getting here. Just, and then once you sample it, you just get a color. So in this case, 1, 0, 1, 1, yeah. Is this sufficient to do what I want to do? So nearest, let's see, what if we could sample from the next pixel? For this one it would be all red, for this one it would be, well, one part would be red, one part would be blue. For this one, it would be blue, 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 blue. Okay, what about this case? So for this one it would be all red, for this one it would be red and blue. But it's this pixel needs to be blended. So if all you do is sample from the next, then this would be blue and this would be blue, so you wouldn't detect this case. Okay, so that's a problem. Like, you somehow specifically need to detect the case where the pixel is in between the pixels. And there's not... yeah, well, okay, what if we had all of the information we could possibly need? What is the key piece that we are missing here? Well, the key piece, I suppose, is like, well, where is the edge? Given some UV, so in this case this is like 0, and this is 1, and this is 0.5. So you need to know that 0.5 is the edge between the texels. And then this pixel is like close enough to the edge that it needs to be blended. I mean, you can work out where the edges between the pixels are. Given texture dimensions and stuff, so that's not really... that part is not hard, although what is the convention here? Exactly. 75, so I'm looking at this pixel here. I mean, if we could just go all the way in the corner. Go in and just take a look at the input. So UV is... okay, so this... it's interesting, right? So is that the number that you get if you take... let's see... I guess it would be easier to just move it to the top left, right? Okay, let's do that. Let's move it to the top left. It's not running anywhere, is it? No. So top left would be, well, we kind of need to know width or height for that. Well, actually, aren't we creating a symmetrical window here? No, we're using defaults. We're using defaults. Let's create a symmetrical window. Okay, that's not what I wanted. Oh, that's the position. Okay, that is a symmetrical window. Now we can just not worry about width over height, aspect ratio, whatever, and just move it. Y would be 10.0. Well, we had top 10, so minus. Interesting. Why is it like that? Oh yeah, because 1,000 does not mean 1,000. That's right. Because the client area is... Okay, let's keep it in the center. So let's just look across one dimension. Go back here, right to the edge. Okay, 0.5. 0.5 is going to be the first coordinate. And is 0.5 what you get? So it's 0.5, but the total size of the thing is is 475. Yeah, so it's the 0, so it's 476 actually. So 0.5 over 476, what's that number? 0.0010542. Is that exactly what we're getting here? Maybe. That's high level variables. Input UVX. Okay, is that the value? Like, are you rounding it, or is that exactly the value? Floating point. Well, it is already. Default. Yeah, well, both of them round to 105. It's presumably rounded. let's see, can we do this? The reference float star address of temp unused variables, yeah, whatever. Interesting. That's a completely different number. Wait, U8. It's not a U8. It's not a U8. Call it a U32. Ah. 10504211. Ah, that. So it is 0.5 of 476. It's that one. Okay, this is also rounding. I mean, can they like force it to not round? No? I see. Well, yeah, I think it's close enough that we can say it's 0.5 of 476. That's what we're getting there. Okay. What was the point of this? Well, what was the point of this? Oh yeah, so 0.5. Okay, so we can see how that translates. So we actually kind of know the texture dimension, because if 0.5 divided by something is that number, then, you know, 0.5 divided by 0.00105,042 is essentially the texture dimension. So yeah, that's interesting. So we can get the texture dimension out of this. Is that enough though? Is that all we need? Yeah, so every pixel, so it's presumably every pixel that just gets a 0.5. Actually, let's see what happens when this is like slightly offset, right? Slightly offset. But not enough to be on the next pixel coordinate. So it's minus 10 plus 2.5. Plus some small number. It's running. Okay, hopefully it's... yeah. Okay, so it's still 0.5. And this is still 0.00105. Did I move it? Didn't I move it like not enough? Okay, what about that small number? How much is that for input? history, debug, input, well there you go, there you go. So the position of the pixel is 0.5, but now this changed. Because we're looking at, like, it's moved to the right a little, so it's like, well, that's the beginning, right? So, hold on. So we used to have it be this way, and now I moved it to the right a little bit. Except that, I mean, I moved the pixel grid. No, I moved the thing that has the texture to the right. So the pixel grid kind of moved to the left. So this is the situation we're looking at. So if you keep moving it to the left, it would be like that, right? So the first pixel will eventually just be outside. But for now, it is inside. What is 1 pixel in these units that we're looking at? So the half span is 10 on the x, and the amount, well, I mean, that really depends on the size of the window, doesn't it? And there are decorations on the window, so we can't even say exactly what 1 pixel is unless we know what the window is. I mean, I guess we can query it here just as a temporary exercise. We can just query the size of the window and then push these things in. Okay, now we know what the window width and the window height is. So we kind of should be able to know what, okay, so half window width. Half window width is window width divided by 2. Except F32, this thing. Okay, there's half window width. And half, like a camera span half x is that. So this is 10, and let's say this is like 500. So if you divide 32 pixels over world units would be half window width over that. That's a floating point already, right? Yeah. Okay, so this is pixels over world units. So if we multiply world units by that, then we should get a pixel out of that. Okay, what is that number? Unused variable, unused variable. I don't know what that number is. Okay, 95. It's a 95 pixels per world unit. I guess that's pixels per world unit, and F32 world units per pixel is, well, it's that but backwards. That. So that is a familiar number, yeah. Okay. What kind of Okay, so we have this many pixels. We need to go 95 pixels to go 1 world unit over. And if we want to go 1 pixel, then this is the movement that we need to make. Okay, so if we move over 1 pixel exactly on the X, let's see what that gives us. Okay, it looks like we moved over 1 pixel exactly. Alright. 1.5. That's the position on the X. UV is that number. Except is it though? Is it though? Input UVX IV. It's the rounding though, like the dereference float star address of so it's still the 0 to, yeah, alright. Which is like the first, it's like 0.5 divided by the width of the texture. Yeah, we saw this before. Oh god. Alright. How do they even do that? It's Windows tab does that, okay. Okay, so if we move half that distance, well, half is kind of ambiguous. Let's move 0.1 times 0. Well, 0.3, let's say. So that should be what? Let's see. It should be like. So this is where we are, and we're moving the texture essentially to the right a little bit. So it's like that. So this is what we're looking at. Yeah. Actually, 0.3. Let's make it like halfway. That's 0.25. Quarter way. Launch. Okay, so it's still here, as expected. Input. Okay, so this is still 0.5 because that's the pixel. This is now different. Okay, this is now different. And what is that? What is that number? Well, instead of being like 0.5 divided by the size of the texture, it's now something else. It's 0.25. I'm guessing. There's 3 zeros, 5, 2. Yeah, 3 zeros, 5, 2, 5. So if you round it, it's 5, 2, 6. Okay, so that's what that number is. Okay. Which kind of means, right, that... Can I do this? Yeah, we can. Kind of? No. Which means that if we keep moving it that way, then at this point it will just be out, because then it will be 0, well, I mean, not out, but like at the edge, I suppose, of the texture. At this point it's at the edge, and at this point it's out. Which, well... Yeah, because we're looking at the pixel center here, aren't we? So like once the pixel center is out, the pixel's out. So the pixel center is in a little bit. So it's really the distance between the edge of the texture and the center of the pixel that we kind of care about. And in this case it's, well, it's 0.25 in, it's 0.25 divided by the size of the texture. Where's the, in pixels it's 0.25, and the texture is whatever it is. I mean, not the size of the texture, the size of the thing that has the texture. Okay. Yeah, it's 476, that number. Okay. It doesn't really help us, well, I mean, what we care about though is this situation where we're in between two pixels, in between two texels. Somehow we need to detect that. We can't just be looking at, well, what's our nearest versus what's the next nearest. It's almost like we want to look at the edges, right? It's like, what's the nearest texel to this edge versus what's the nearest texel to this edge, and then blend them together based on where this edge falls. I mean, we can do that, right? Because we know the coordinate that's being passed into us is the pixel center. We essentially know how to go from that to the coordinate with the pixel edge. And we have a sampler that will just give us the nearest texel color to that. Okay, I think we're gonna need that. We're gonna need some more things though. Let's start there. Well, okay, how do we go? We want to know what the size of the pixel is in UV units. What we're getting here is well, like if we look at the y, this is the pixel coordinate. Right, it's the pixel coordinate. And this is UV texture, so yeah, so this is the pixel coordinate on screen, and this is the UV, you know, within the texture. So so without knowing the offset, we can't really. I mean, I suppose we have to pass in the texture dimensions then. Which for now, well, for now we know it's 32 by 32, so we can hard code it. I believe, right? Where's the texture? It's, yeah, 31, 31, 30, yeah, so it's 32 pixels by 32 pixels. Where's the, yeah. Oh god. Yeah, it's 32 by 32. Okay, so let's just do float text. Dim is float 2, 32, 32. Obviously this pass in. We have to pass this in. I don't think HLSL gives us access to such basic information as the texture dimension that it's sampling from. We're not allowed to know, unless we pass it in ourselves. Which might as well do it in this buffer, I guess. I mean, it's not gonna change. But, you know, it's not a lot of data. So there's the texture dimensions, hard-coded. So 1 over 32 float to so once you go 32 pixels over, that means you've gone through the whole texture. So movement by 1 pixel corresponds to a UV movement of 1 over 32. So it's like UV per pixel, I think. So like if you take pixels and if you take 32, the pixel coordinate like 32 and multiply it by that, you get 1, which is the UV that corresponds to, I think that makes sense. Okay, so that's the UV per pixel. Now hold on, let me just look at the reference again. Okay, here. Okay, we have a pixel coordinate. Is the pixel coordinate even helpful? Or is the UV all we need, really? I think UV is all we need. Okay, UV per pixel float to half UV per pixel is UV per pixel times 0.5. Okay, so then so for now let's think of the x dimension. Float left is input UV x minus half UV per pixel x. Float right is input UV x plus half UV per pixel x. Okay, so that's left and right. And I mean, we could just fill in top and bottom for now. Top is input UV y. I believe that textures are top down, so top would be minus half UV per pixel y. Bottom is input UV y plus half UV per pixel y. Okay, so this should be the left, right, top and bottom edges, but in terms of the UVs. Okay, so if we look back here, we kind of need, like, what happens when there are 4 pixels? Let's extend this a little bit. And I have a pixel like over here. Well, I mean, I guess we don't really need that whole. Let's just put 1 pixel here. So left, right, top, bottom. Okay, so what's happening here is, I guess it's the corners really, not so much the edges. Like we need this corner, this corner, this corner, this corner, and we need to blend, you know, do a bilinear blend ourselves essentially across these corners. Okay, well, let's do the corners. Float to top left is float to top left. Float to top right is float to top right. Float to bottom left is float to bottom left. Float to bottom right is float to bottom right. Okay. We have the corners. Probably, I mean, let's see, does this compile? It compiles. Let's take a look at the numbers. Actually, what are we looking at right now? We're looking at... Yeah, it's shifted a little bit. Yeah, it's shifted a little bit, so let's... well, I guess let's not shift it. Let's just have it be well, there. Let's just have it be exactly where it is, where it's easiest to debug. Launch, save, no, capture. Yep, okay, let's look at that pixel. Debug pixel. Okay, did it remove all the stuff that I want? Is that what happened? It's not used, therefore we're just gonna remove it. Yeah, looks like that's what happened. Amazing. Well, yeah, why would you actually do anything with the code that I wrote? Let's just remove it. Like, it's not doing anything, you know. I know we didn't enable any optimizations, but we're just gonna remove that code anyway. I do have optimizations disabled, do I? OD. Maybe that's not what we want. FXC, help, temp, OD. Disable optimizations. No, it is what we want. Okay, I guess like that code elimination does not count as an optimization. Like I did recapture it, did I? Yeah, that code elimination does not count. I see. Thank you, Microsoft. Okay, so what do we need? So we have the corners. Now we can get the sampler to sample the texels from those corners. Got top left, top right, we've got bottom left, And we've got bottom right. Okay, so there's the 4 colors. Okay, that's the 4 colors from the 4 corners. Okay, so we need 2 blend factors, right? We need to know kind of like relative to the pixel center. Where, so we have the, well, we have a UV that corresponds to the pixel center. That's what we have. And we need to know, like, what's this essentially? What's this line? Like in this case, the way I drew it, it's like 0.025. And this is like 0.2. Okay, how do we work that out? And more important, and also, like, what happens when all 4 corners sample to the same color? Well, in that case, I suppose it doesn't matter because, like, however you blend it, as long as the blend factors are, like, as long as the blend factors are making sense, it's just gonna blend to the same color anyway. Okay, so we need to work out what this is. It's almost like we want to know the coordinate of the nearest pixel edge or something like that. Pixel edge. So we have the texture coordinate. In this case it's 2 by 2. And we have the UV, which in this case is like slightly over 0.5. Well, when there's only one horizontal and vertical edge, of course you know where it is. It's at 0.5 exactly. But and if this is slightly over 0.5, then like 0.5 minus that, like that distance from the pixel center, except, well, I mean, once you know where it is, you can take the distance from the edge, because you know what the edge is, right? So you can just take that and have that be your blend factor for horizontal blending, and do the same vertically. Whereas with this one, so is it just the, I mean, there's 2 edges here. There's this edge here and an edge here. And this one is it, so this is 0.51. And this coordinate would be like 0.7 or something. In UV space. Or 0, 1, 2, if we take the edges to be like whole number coordinates. So if this is 0, 1, 2, because we can transform to that, because we know what the texture dimensions are. Well, actually, would it be that simple? Can we just transform UV into an actual textile coordinate and just work from there? Because then this would be like something, well, on the x this would be like 0.99 or whatever, and this is 1 point something rather. And then this factor, I mean, this is 1, right? So all the edges would be at whole numbers. And once all the edges are at whole numbers, then the distance to the edge is just you floor or ceiling the number or something, and then they kind of have it. Alright? Okay, so these are the actual colors. Text top left. I mean, text color. Top left, bottom right. And, well, text coordinate. Top left is top left. Okay, well, let's make it a little less ambiguous, I guess. Top left is, I mean, I guess that's UV, top left. Top right is UV, top right. Bottom left is UV, bottom left. And bottom right is UV, bottom right. Same with left. Okay, text chord top left is UV top left times texture dimensions. So 0 would result in 0, and that, like, 1 over 32 would result in 1. So that would, whole numbers would fall at the edges. Top left, top right, bottom left, bottom right. Okay. So these are the coordinates for the 4 corners. Okay, so then if we so if we take the left, so do we even need that, or can we get away with essentially just this chord left, text chord, yeah, is, well, it's UV times the corresponding UV times text. Alright. That. Okay, so we don't need this actually. We do need this for sampling colors. Alright, so there's the UV for the 4 edges. There's the text chord for the 4 edges. Now if we take the left edge, let's say, and well, if you floor it and subtracting, you'll get this number. If you ceiling it and subtract, then you get this number, which is the blend factor in this case. The horizontal blend factor. And is it always going to be like that? Like in this case, I mean, in this case, the left edge will be negative, won't it? Because it's like outside the texture, so that's Well, I mean, I suppose if every texture just has like a transparent border, then nothing's really going to be outside the texture, presumably. Assuming we correctly... Well, no, the pixel center it's the pixel center that matters. The pixel center is still inside the texture, so nothing's really outside. But the left edge is outside. So what's that going to be blended with? Like, I mean, it depends on what the texture sampler returns. Like, we're gonna have to take a look at that. Okay, so if we just ceiling the left, okay, let's see. So like, do we have ceiling? Yes, 20 overloads on the ceiling. Text chord left. Well, I mean, let's minus text chord left. So like, is this it? Blend X. Like, is this it? I mean, it's gonna be negative in this case, right? Because this is like, you step over here, that's gonna be negative. So if you're sealing the negative, I mean, I don't even really, what's gonna happen with when you're sealing a negative number here, I don't know. Yeah, definitely have to take a look at that case. But in this simple case, where we're not at the edges or corners or whatever, if you're sealing it and then subtract, then you get a blend factor that's that makes sense. But okay, what happens here? There's the left edge, you're sealing it, subtract, you get this number. Okay, so I guess you're gonna have to clamp it. Do we have a clamp? We do. Well, 0, 1, obviously. Okay, so in this case it would be 1. I mean, in this case it doesn't matter. As long as it's between 0 and 1, we can use it. Okay, so the same happens for Y. Blend Y is text chord. Okay, so it's top down. So if we, so this is going to be like 0.9, this is 1. So if we ceiling and subtract, chord top minus text chord top and clamp, so that's blend Y. Okay, well now that we have the blend factors and the 4 colors, float for okay, so let's add blend factor. So there's the colors. Now blended top would be text color top left. So we are blending, okay, well, we are blending top left and text color top right. Okay, we're blending these two by that factor. So it's when the blend factor is let's see, when the blend factor is 0, that means, okay, so we're multiplying it here, and then adding 1 minus here. Blended top, blended bottom. And then blended would be just do a vertical blend between those two. So like top, from top to bottom, and this would be blend factor y times that plus 1 minus okay, so we're not doing anything with gamma here. Okay, well, to do gamma. Okay, that's for later. Okay, so there's the blended color, maybe. Okay, we don't really need this anymore. Okay, now just that, right? Implicit truncation of vector type. Yeah, that is a problem. $65. Oh, textdim x. Textdim x, textdim y, textdim y. Okay, I have no idea what this will produce. No, it produces something interesting actually. Huh. It's as if we turned on bilinear. Oh, that's yellow at the edge there. Interesting. Okay, hold on. Is it exactly at the... Yeah, it's exactly at the edge. Alright, well, there is some kind of blending going on, to be sure. So, well, I mean, the thing that happens at the edges, though, is... Well, actually, let's see what happens at the edges. Precisely. So UV per texel is that many. Okay, UV left, right, top, bottom. Text chord. Okay, well, let's see. Well, not all of these are used, are they? Yeah, let's actually let's remove the unused. So we only need left and for the blend factors here. Okay, we're not using right, we're not using bottom. Okay, let's look at the edge. Yeah, let's run through that. Okay, blend factor 0.4, 0.4, interesting. Okay, so what's the text chord left? Text chord left. We're not allowed to know what text chord left is. We're not allowed. Are we allowed to know what UV left is? Ah, there it is, it's negative. Yeah, well, that is gonna be an ever-present kind of problem. Because UV here, and then, yeah, so I mean, that does make sense that it's negative. in this case. I mean, I guess I just want to run to the end here. Just look at all the values, because I'm not mutating any of them anyway. Wait, does it remove variables as you go through? Is that what's happening here? Like if I write UV top left, you piece of shit. Okay, let's go back. How do you execute backwards? Shift F5. Step back. Ah, yeah, just hold Shift to. So these are like. Yeah, top and left, and then the blend factor becomes that, and okay, well they are the same, which kind of does make sense. Why does it throw a cursor here if I can't type anyway? Like, what's the point? Why is it doing that? Okay, I need to take a toilet break. Just mute. Yeah, actually, I don't think it makes sense that these numbers are negative in this case, because we are aligned. Like here, I didn't move anything, right? We are aligned. So I think I'm multiplying by the wrong things. Yeah, so that right here. Let's actually examine those in more detail. Can we like shift F10 up there? UV per texel. Texture dimension is 32. UV per texel is that 0.03. And input UV on the X side is 0.001. Well, no, this part actually does make sense, I think. What doesn't, well, UV left, UV top, UV right. Okay, so this stuff actually also, well, it makes sense as written, but it's not actually what I wanted to calculate. Because like we have a UV coordinate, which is great, but then we go like forward by that. Yeah, that doesn't make sense. What we need is to do that with pixels, not UVs. Okay. Okay, so this is the pixel center. This is the left. Okay, well, so the approach, I think, more or less works, but you know, we need to do it correctly. So how do we do it correctly? We have a coordinate of the pixel center, which in this case in RenderTalk, it's 0.5 on the x. So that is the coordinate of the pixel center. So the coordinate of the pixel edge would be 0 and 1. And then we need to know what the UV would be. So yeah, there we go. So we need to know what is the UV if the pixel coordinate is 0, let's say, or if the pixel coordinate was like different by 0.5 specifically. Yeah. Okay, how do we work that out? What is the UV if the pixel coordinate is slightly different? Well, we don't work it out like that. Because it's UV per pixel that we're interested in, not per texel. Yeah, I think that's what the problem is, mainly. I think we are gonna need that though. So the real thing that we need here is we need the size of the thing that has the texture. On screen, like in pixels, which can we get that? Alright, so go back to the diagram. What would be the texel coordinate if the pixel coordinate was slightly off? What we have as input is the texel and the pixel. So there's the pixel and there's the texel. And there's the y and there's the okay. So in this case it starts at 272 vertically. And then this is just 0.5 divided by its vertical size. So like vertically we would ask, well, if the pixel coordinate was 272 rather than 272.5, then what would this be? And the answer would be 0. And then the same question is, well, what if it was 273? And the answer would be, well, it's this plus half of that. Because it's the first pixel. So really, if you, this 0.00105, this number is, it's the it's if you increase UV by that amount, you're moving half a pixel on screen. So it's this half. So it's half UV per pixel essentially is what that number is. It's half UV per pixel, and you work it out by taking 0.5 and dividing it by the dimensions of the thing that has the texture on screen. As in like the texture span, I guess. Pixel texture span. I see. Well, I mean, the pixel shader will just interpolate things for us, won't it? So, like, instead of passing in UVs, we could just pass in, like, the corner UVs. Maybe. Can we? And just have them being interpolated correctly, pretty much. Can we do that in the vertex shader? Because then it will step by and presumably interpolate them correctly. Well, that's interesting actually. So we are passing in UV0 for that first vertex, and then it gets interpolated to 0.5 because 0 is like the edge of the pixel. And what we're getting in here is the center. Does this text chord, does that have a special meaning? Like, what if I name it something else? No, it doesn't have a special meaning, so it just could be named anything. And it'll still get interpolated. Okay, so what's happening here then? The vertex shader is outputting, okay, so is outputting UV00, and then the pixel shader interpolates that to 0.5. Well, not 0.5, but like, it's not 0, 0 that comes in, it's as if the pixel coordinate is 0.5, so 0, 0 is like the edge of the pixel. Yeah. So the pixel shader interpolates these things in such a way that it's equivalent to, like, in the vertex shader, what you're passing in is what's happening at the edge, and then in the pixel it's what's happening at the center. Well then, what happens if I pass in more stuff? What if, so this is like UV... Because we have the dimensions, right? We have the dimensions in clip space right here. Float to, well, I mean, float to UV top, let's say. Do we need this stuff? Like, maybe. And float UV let's see what happens there. UV top and UV left, let's say. That's what we've got. We have the position and the dimensions in clip space. Which then gets interpolated into like pixel space. So, alright. Can we come up with what should be output UV left? What's this? Well, it's this UV. It's this UVX minus what? We're in clip space. I guess this would be pix dim in clip X. Except half. And top would be this UV Y minus pix half dim and clip just half dim clip. Okay, so if we could just work out the pixel dimension in clip space, that would be pretty good for this. Well, for that we need to know the window dimensions. Oh, God. Alright. So this probably also needs to be passed in somehow. We're just gonna make it full screen. Pass it. Okay, so these are the window dimensions. And so they go from 0 to 2560. So if we just if we take pix dim clip, what are the pixel dimensions in clip space? Well, window, well, 1 over window dimension would be almost what we want. Times 2 minus 1 is what we want. Yeah, because this is essentially saying, well, if you go 1 pixel to the right, let's say, well, if you divide that by 2560, that's the proportion of the window that you went, and then the range of clip space is 2, so you multiply by 2, and it starts -1, so -1. I think that makes sense, yeah. And float to pix half dim clip is pix dim clip times 0.5. Okay. That compiles. So all of this goes away. Except not all of it. This definitely goes away. Well, we do kind of need world units per pixel, so that we're gonna leave. Half span X, yeah, so that's gonna be set here. Okay, let's just move this out. this is just getting the window dimensions because we don't know what it is at this point. Yeah, this is just here to move the thing around. We don't actually need the window height because we're only moving things around horizontally. So that's fine. And there's some phantom error. Did Clang D just shut itself? Of course it did. Okay, so there's our half. Now, make the window full screen is what I want. So at window creation, pretty much, we'll just do toggle full screen. Of course, we have to look up how to do that every time. Raymond Chen full screen. Devlog, yeah, that's what that is. Yeah, that seems like what we want. Okay, well, we don't need that. Window placement. Yeah, that's just us remembering global window placement. I'm guessing this is this is toggle full screen, and it takes in the window, X and Y, and the key flags. And I mean, it might as well. Hold on. Yeah, that's fine. That is the monitor info. Okay, this is just like what is going on there? And if get window placement and get monitor info, then set window long, set window pause, oh yeah, we've got conventions here. Okay, all of this is just flags, I see. Does that compile? Unused parameter. Okay, a lot of unused parameters, to be fair. Missing initializer, missing field initializer. CB size. Okay, so that compiles. Does it work? Let's see, I'm gonna just call it here, toggle full screen. Well, window. toggles full screen. Yeah, let's just tap this out. Okay, that's all good. This previous window placement thing, might as well put that into the window. Window. Yep. And I guess Alt Enter should be bound to that. Where's our message loop here? Key down and sys, key down and key up, and sys key up. Wait, key up. Key down, key up, sys key down, sys key up. Okay, well, so there's Alt F4 and there's Alt Enter that we need to handle. Is this actually good enough to be able to do that? Because it's like, well, if you press Alt and then F4, that's different from pressing F4 and then Alt. Like F4 Alt shouldn't quit, presumably, yeah. So you do kind of need to know when these things are pressed. And in what order. Or is there a simple way to just get there from the keyboard state? No, that and that. All we know is if the keys are down. We don't know if they're pressed unless we compare with the previous keyboard state. And it's just, we will know that they're pressed. But then you would have to say, well, if this key is pressed and the previous time it was also pressed. Yeah, okay. If keyboard is pressed and down mask. Well, I guess if F4 is pressed and the Alt key is down, that counts as Alt F4. Does it? I mean, or is it just easier to intercept them here? Because all we have to do here is like if message, okay, which param is it again? Key down. W param is the key code. Is VK enter or VK return? Yeah. Well, yeah, like this case. Oh wait, what? No, it's not the case VK return. Toggle full screen window hwind and the window placement. Actually, might as well. Why is there a break there? That doesn't make sense. Not that. And VK F4 should just be go to break main loop. Okay, so these are the only sys key downs we're interested in. Move key down, key up are intercepted. Sys key down, if it's an enter, then toggle full screen. If it's an F4, then break. Sys key up is intercepted. Quit is just that, and this is the default. Okay, Alt Enter. Okay, Alt Enter. Does it work if we move it? Yes. Alt F4? Yeah. Alright, so now we're launching in full screen, which means we can actually use this, because these are the correct coordinates. I think. Correct size. I mean, we couldn't verify. Just here. Window width 2560, yeah. 1440. Yeah, okay. So all of this was for what? Not for this. Alright, so yeah, all of this was to examine the pixel shader output. What's the pixel shader gonna tell us? So if we look at the very corner, what's in the input? Interesting, so 0.5. Huh. We got some weird 0.5s, which is definitely not what it's supposed to be. Probably because it is a corner, so yeah. yeah, it's that vertex. Okay, window dim, pix dim, and clip. My god, Shift F10. Pix dim and clip. It works out to be. Wait, well, that's wrong. That's wrong. -0. Divided by window dimensions, that would be some small number. Wait. So what I'm trying to do is like, well, if we've got 1/2560, right, it's that number. So that's the proportion. Times 2 actually times 2 is all we need, right? Because we're looking for dimensions, not like a coordinate. That doesn't make sense. Okay. So that's actually all we need. Okay, let's close all these debugging sessions. Capture frame. Okay, let's take a look at that again. Well, actually, let's take a look at the vertex. It's not even throwing them here. Okay, window dimension, pixel dimension, half pixel dimension is that. For some reason it's... No, it's in clip space, so yeah, that actually does make some sense. Camera half span, position, vertices. Okay, so the output, UV top, UV left. Well, I mean, that is kind of true, because 0, 0 will like translate to, well, that's what's happening at the center, and these other ones, that's what's happening in the corner. Oh my god, okay, now let's debug a pixel. Okay, what's in the input? Interesting. Okay, so it got interpolated to something. Which I kind of expected this to be 0, 0, right? Not whatever that is. No, because it's not... I see. So pixel have dimensions in clip space. We can apply that to position, but not to the UV. That's UV is different. Yeah, we kind of want to say if the pixel half dimension in clip space is this number, what we're really interested in is, I guess, pixel dimension in UV space. because this UV, like this UV 0, 0, that's the pixel center. And if you go over by like 1 pixel to the right, how does that affect things? Well, isn't that just 1 over the dimensions in pixel space? Like, we have the dimensions in clip space right here. So we know how many pixels the whole thing takes up. Flow to dim in pixels is dim in clip times pixel dim, or, well, divided by, I guess. Dimensions in the clip space times no, this is over pixels. So, well, it's divided by. If we take dimensions in clip space and just multiply them by 0.5, which is scale in clip space. You multiply that by 0.5. That would be the dimensions in a 0 to 1, and then just multiply that by window dimensions. Isn't that it? So like scale and clip times window dimensions. I think that's all we need for dimension in pixels. And once we have dimensions in pixels, well, if the dimension in pixels is 100, then for every 1 pixel movement, you're moving 1/100th. So then pix half move pix half UV, something like that. Pix half UV is 1 over that. Okay, so we don't actually need this. Okay, let's debug that again. Dim in pixels, so I wanna know what that is. Dim in pixels, 640, 640. I think that's right, because it's square, right? Yeah. Yeah, I think that does make sense. Pix half UV is that number, 00156. Okay, so UV left, right, turns out to be that number. So UV is 0, and that's minus minus, because the square, the texture square. So I think that makes sense. Okay, well if that makes sense, then let's see what's going on in the corner. Well, first of all, what's the input? Okay, interesting. Interesting. Oh wait, that's not half UV, is it? That's just UV. So it's that times 0.5. Okay, so close that, launch, take it. Go to the corner. History, debug, input. Okay, so those are zeros. Okay, finally. Okay. So we can get the GPU to interpolate the things that we want. Okay, so let's just do that for all the edges. Left, top. So we don't even pass UV, I'm guessing. We just pass the 4 UVs. Top, left, right, bottom. Top, left. So do we need this alignment? I don't know. I don't know if we need that. Make it top, left, right. And bottom. Okay, there we go. So we have position, we have top, left, right, bottom. Top, left. Wait, why is it in that order? Top, left, bottom, right. Top, left, bot. I mean, this makes sense to be just that. And this is bottom. Okay, so top, left, top is y, bottom is y, right is x, UV is the top is minus, left is minus, bottom plus plus, right is x, left is x, top is y, bottom is y. Okay, so that makes sense. That makes sense. To do gamma, pass in texture dimensions, actually, do we even need those, really? Maybe. Okay, what's going on here then? So, okay, well this we don't need to calculate because we kind of just have that in the input. Not that input. Okay. Input. Okay, so we can construct these UV top lefts, UV top rights, whatever. And we don't need these anywhere else, I don't think. So should we just transfer them over, like there? like that. Okay, so we have the colors. The colors are not a problem for us. We can just work them out here. Blend factors. The real problem is the blend factors. How are we working that out? Well, I mean, we do have this. Left and top. Yeah, so we have the UV for left, we have the UV for top. So ceiling, you know, that minus clamp. Okay. And then do the bilinear blend between those. Okay, what does that produce? Huh. Well, that produces something closer to what we actually want. Now, the edges are a problem. Also, why is it like flipped vertically? Like, when did that happen? Like, if we take a look at the, do we have the, hold on. Let's capture. The texture doesn't look like that. It's like flipped 90 degrees or something. Okay, well that's one problem to fix. We have. So this is correct, but like this isn't. Is that the vertex shader messing us up a little bit? Top is this UVY minus this UVX, this UVX, this UVY. That seems fine. Mesh viewer. Input, output. So this is top left. Like 0, 1 essentially. Zero, wait, V left. 0, 1, 0, 1. Yeah, that kind of makes sense. 0, 0, 1, 1. Yes. Why is the texture flipping? Like, what's going on there? Is it the pixel shader? That's like, well, I mean, I guess we can just go here, right? Because we know that's over there. Top left, top right, bottom left, bottom right. Input 1, 0, 1, 0. So it's 0 on the x and 1 on the, wait. Wait, hold on. Why is there... Yeah, these are close. These are close together. So this is actually 0, 1. Okay, so text color, bottom right, bottom left. So it's all magenta. So what? Oh, because I'm passing them in backwards here. Yeah, that'll do it. That'll do it. Okay, so if you pass them in the right way around, presumably that'll fix that problem, at least. Okay, so that one of the problems is fixed. We still have the problem that the edge is not behaving correctly. But what's going on with our, like, with these edges? So what we should be seeing is that they're not jittering left and right quite so much. And I think that's what we are seeing. I mean, it's fairly smooth, although I'm gonna have to verify. Because who knows what else I did backwards there. How do we verify? Well, let's move it like a little bit to the right. World units per pixel. Well, not 1 pixel to the right, but like 0.25 pixels to the right. Launch. Alright. Okay, what's going on at the edge there? It's actually kind of unclear exactly what's going on at the edge there. But we have moved this thing, right? Okay, well, not. Okay, I'm not seeing. Am I? Let's move it halfway. There it is. Yeah, so we are seeing them blend together a little bit there. And these ones are blending together as well. Of course, the edge isn't blending with anything, so that's a bit of a problem. But these are blending, these are blending, these are blending, these are blending. The edge, oh yeah, unclear what's happening at the edge, or should be happening. Yeah, alright. Okay, so it seems like it's wrapping around is what's happening there. It's just wraps. And I mean, we do control that behavior to an extent, don't we? Yeah, well, I mean, we told it to wrap. What else can it do? Mirror, clamp, water, mirror once. Clamp, I guess. Okay, I think this is doing what it's supposed to be doing. Seemingly alright. Well, I mean, if we move it almost all the way to the right, capture, quit, and then take a look at this. Okay, well, the edge is like it's got nothing to get. There we go. Is that really what it's supposed to be? Like, this seems a little... I mean, it should be almost all the way blended. No. Debug pixel. What are the blend factors? On the Y it's 0 because it's lined. Presumably. On the X is 0.5. Because text coord left is not visible here, so yeah. Text coord left is 1.95. Is it? How is it 1.95? Shouldn't it be different to that? I mean, this is the first row. I mean, I moved it almost all the way. Like, if we, hold on, if we move it all the way, does it align? Let's see. It does? Yeah, it does. It looks so. So if you move it all the way, it does align. There's exact like edges here. No blending. And verify. It's in the blend factors. 0, 0. Yeah. Text coord top is 2 and text coord left is 2. For this pixel. is it? Oh, texture dimension is 32, 32. Well, I mean, if you just multiply the UV, then that's what it turns out to be. 0.0625. Top, bottom, 0.06. 406. So 64 to 625, 64 to 625. I mean, it is square, so that part at least makes sense. 6264. Well, if you just multiply this left, which is 62, by 32, you get 2. Okay. Is there an off by 1 somewhere, maybe? Because this is 0 and this is 1. 2 would be that one. So that doesn't really make sense. So if we go back to alignment, to the left edge, well actually, I mean we're at alignment now. What if we just look at the left edge here, let's say. 1.9, well, 0. Okay, that does make sense. 0. So blend factors are 0.1. That's 0. Oh, there's apparently a Y blend factor. Which there shouldn't be. Huh. Text score top is 1.9. No, wait. Text score top 2. Yeah, so it does work out to be something. The blend factor. Why? Well, even though it shouldn't necessarily, although should it? Well, I mean it's all the same colors, so no, I actually yeah, the Y is fine. It's the X that's interesting. main thing is that blend factor x is 0. Text code, okay, 1.9 and 0. And if we look at this edge, one point four, 1.95 for the left edge of that pixel. We are aligned. So all the colors that it's blending should be the same. They're all the same. So is it, so then is it doing what it's supposed to be doing, except that the blend factor is wrong? Is that what we're seeing here? Like if we move it halfway on the X, and then take a look at it here, yeah, that pixel is supposed to be blended. That's half of what it's supposed to be. It's exactly half of what it's supposed to be. Okay, what's text score the top? Oh, left, rather. 1.975. Is that what we'd expect it to be? For the left edge, if it's halfway between, like if this thing is like halfway, and then the center would be exactly at, 1, let's say, in this case, so 2. And the left is presumably where it's supposed to be. What is this that I'm missing here? Text scored left 1.975. So you're just sealing it, subtract, and what you get is half of what you expect. What I expected is point. Wait, it's not even half of what it's supposed to be, is it? Wait, is it? Oh no, it's very small actually. It's I think we're missing some kind of scaling factor there. Yeah, the blend factor is way too small. It's not even half of what it's supposed to be. It's half, and then it's like 50x smaller or something. Yeah, because position is halfway. Well, the center of the pixel is at 40.5. So we can get the texture coordinate. Okay, hold on, if we go back, again, it's not really the texture coordinate that gives us the blend factor, is it? It's how far away this edge is from, well... It's how far away this edge is from the whole number. But in terms of this, there is this missing scaling factor. So far what we worked out is this, but in UV space. So that's not really the blend factor. We also want this in the UV space. So it's like, it's this in UV space divided by this in UV space. As in like the pixel size in the UV space. Okay. What's the pixel size in UV space? Well, it's UV right minus UV left. Via the x. It's like UV, blend factor x is blend factor x UV divided by input UV right minus input UV left. That. Right, so it's this divided by that span. And y is the same. So blend factor y input UV bottom minus top. So we're getting something out of that. Except it seems to be blending the wrong colors, but like it's 1 over almost. And 0.975. Okay, what are these blend factors? Okay, why is that so big? What? Hold on. Oh, because I clamped it in the wrong place. The clamp, it does not belong here. Okay, let's see, what have we even drawn? We've moved it halfway, is what we're drawing. I'm not really seeing... Okay, the color is definitely different. So the right, the left, let's pick a pixel that's a little easier. That one. Okay, text color right, left. Because the colors are all the same. Point 4.3, 0.42. I mean, if it's moved halfway, at least one of these should be blended, you'd think. I'm not seeing any blending at all now. Is it this one? Right, left, right, left. Okay, well, this is it then. So we're getting different colors. By the looks of it, they aren't blending. But at least we're getting different colors. So this is the pixel that should be blended. Okay, there's the texture coordinates. Okay, X and Y blend factors. Well, X is the one that I'm interested in, really. That's in UV space. I see, okay. Let's break this up. Pix dim UV. Float 2. That's right minus left, and then it's bottom minus 2. Okay, so now this can be X and Y like that. Can I just do float 2 for blend factor? Let's see. Clamp, blend factor, float 2, blend factor X. Actually, even this can be done. Top left is just float 2, left input UV top times text dim. Okay, there we go. Text core top left is ceiling, text core top left minus there. So this would be blend factor UV, pixel dim, blend factor is blend factor UV, divided by pixel dim. Yeah, okay, blend factor X is blend factor dot X, blend factor Y is blend factor dot Y, there. Okay, 73, implicit conversion of vector type, something, float 2. Okay. Okay, I think it's this pixel that's supposed to be blended. Okay, what are the colors? Are we on the edge of something? Yeah. Let's look at an easier pixel than that. 0.6, 0.600. Okay, so that is correct. So black and okay, text core top left. Text core top left. 1.975 on the X there. 0. Okay, so that does make sense. Ceiling minus, okay. Pixel dimension UV. is in UV. Okay, so it's square, so that makes sense. 0.00156. Okay, blend factor UV divided by pixel dimension UV. Okay, well, blend factor is a lot bigger than singular pixel dimension, so that doesn't seem right. So it just ceilings to 1, or clamps to 1, because this turns out to be something that's much bigger. Okay, well, at least we got the problem down to just figuring out what the blend factor should be and how to get it out of UVs. It's the input. Hold on, it's not blend factor in UV, it's blend factor in X coordinates. There, it's it's the blend factor in the text coordinate space. Ah, there we go. So we actually want the dimension of a pixel in terms of texture coordinates, as in how many pixels are there per text. Oh god. Well, it is this, but it's times TextDim. So let's pixdim text coord. Okay, this is kind of complicated, to be frank. Okay, well, this looks more right than before. Yes. So look at this pixel. We debug that pixel. What's the blend factor? 0.5. Alright, we got it. We got it. Let's try other values. So that's 0.5, 1, 2, 3. Well, close enough. How about 8, 9, 4? 894, yes, okay. Well, we want to make sure that on the Y the same thing is happening. Span Y is camera half span X times height over width window times window Actually, it should be the same, shouldn't it? No? Oh well, it's, yeah, because we're multiplying that which is dividing by that, so it's the same as as camera half span X divided by half window width, right? It's the same. Yeah. Okay, so this is just world units per pixel. We don't need this. Okay. Let's go to H. And okay, so then now the Y, let's just move it world unit per pixel times 0.5. Let's move it half down to make sure that it's blending vertically. So we have some pixels to look at there, so it's that one. So I just want to know what the blend factor is. 0.5, that is correct. Okay, let's try some other value like, wow, okay. Let's try some other value like 0.1. If you move it, so blend factor from top to bottom should be 1 minus what I moved it down by. Right? So it was like this and I moved it down like that, so yeah. this is 0.9 from top to bottom. So that is correct. So if we move it by 0.9 down, that's 0.1. So you move by 0.9 down, so now this is 0.1 from top to bottom. Except I'm moving it up, am I? Yeah, this is positive. So like you move, so it was here, let's say, and I moved it up by 0.9. Like if I move it by, this is world units, by 5, where is it gonna be? Yeah, it's way up there. So positive numbers go up. Okay, well then if I move it by a positive number, which this is a positive number. Yes. So if I move it up by that amount, then it should be 0.1 from top to bottom. And yet it somehow isn't. So I move it up. So this was, and there's 2 pixels there, right? One red, one black. The black one, let's say, kind of moved up into the red. Huh. Yeah, that's not right. Text color bottom, text color top. Top is red. Yeah. Text core top left. Well, the top is what is that? 0.195. So the blend factor becomes 0.05. Pixel dimension is 0.05. How does that work? I mean, hold on. Am I just not... When you move it into the positive... Wait, I think it does make sense. because here we are moving it into the positive direction and the blend is in the same direction, it's left to right. But here we are moving it into the positive direction and the blend is in the opposite direction. So it should make sense that it would be 1 minus what I moved it by. Presumably, except that, you know, how do I demonstrate that? Hold on. Let's take 2 pixels. And then I moved it up like that. By 0.1. So like if it's here and you move it, if the pixels is here, and you move it to the right, if you move it to the right by 0.1, shouldn't the blend factor become 0.9? For the X movement? I mean, one is definitely the opposite of the other, but like here, we're moving it almost all the almost all the way to the right, to the next pixel, right? And the result of that blend is that pixel. Presumably. Is it? I mean, it is almost black, so like that is what you'd expect to see. Something that's almost black. Except I don't really get it, how that works out, because if I move it to by 0.9 over here, should it be almost black? I mean, it's like the black is moving towards the red. Shouldn't it be almost red instead? Oh yeah, it is the opposite of what it should be, isn't it? Because this edge pixel should become more and more red. Like, this is what it should look like at the beginning of the movement, not at the end of the movement. So like if you only move it like a little bit to the right. Is it being blended? Am I looking at the corner pixel again? Yeah. Right, left, yes, it is being blended. And blend factor is that. 0.0005, even though I moved it by 0.01. Well, that might be floating point problems. 0.01. 0.01. Text record in the top left. I mean, if we go back to the diagram there, interesting. If we go back to the diagram, so I moved it a little bit here. So we should see a pixel go from black to red. And yet we're not really seeing that. I mean, everything's basically black now. And then if we move it, well, move it by 0.1 to actually see the blend. Instead, we're kind of seeing a pixel go from red to black. Like this edge pixel becomes slightly black, and then it becomes all the way black. Wait, is that what we are expecting to see? Oh my god. And now we move it by 0.9. And like there it is, it's almost black. Is it even? And this one's almost red. Okay, so this is a pixel at 4040. X is 40. Yeah, it's the same pixel. I mean, in principle, this is correct. Is it? It's... The pixel that's slightly red is becoming slightly black, and then it's even more black. And it's a pixel at 4040 that's doing that. Okay, so when we are... Well, yeah, I mean, we could make that pixel become more black, or the previous pixel become more red. And And I guess that's equivalent. Yeah, like those are equivalent things that can happen. Although it seems like one of them is more correct than the others. Although maybe not. Like this corner is being blended as well, which is what you want. So maybe this is exactly what we want, actually. What's the vertical movement there? 0.1. And we have the equivalent situation, right? We used to have this pixel here at y is 439, which was all red, right? And now it's slightly black, which is correct. Y is 439. Let's make sure that it actually is all red. Yeah. It's all red, and now it becomes more and more black as you move up, which is what you expect, which is correct. And it's this pixel. So on the diagram, I guess I'm looking at kind of the wrong... Oh yeah, because on the diagram I'm moving the pixel grid, that's right. So when you move something up, so when you move the texture to the right, that's the same as moving this to the left. So when you move it by 0.1, the blend factor is 0.1. And can we bring to top? Yeah. And right here, when you move something up, that's the equivalent of moving the pixels down. So we moved it up by 0.1, and the blend factor is 0.9. Okay. Right. I think I figured it out. Okay, so this is about as smooth as it's ever gonna get. Can we like easily compare them, I wonder? And I guess we could, if we just pass float to UV, and then just pass it here, output UV is this UV, and then just do result is input well, actually right here, blended is that, now we're just gonna sample from the UV like that and undo all the work. So this is how it used to be, I think. Yeah, is it? Is it compiling? Yes. I don't think that's what it looked like. And hold on, let's take a look at the positions. Now we moved it a little bit to the right on the X. And there is no blending. No, there is blending. Let's move it halfway. Okay, there's no blending. Now comment that out. There is blending, to be sure. There is blending. It's halfway. Okay. So this is with our blending. I wonder if it needs to be moving slower for the difference to be more obvious. Yeah, I think the more edges you have, the more obvious it is, and the more frequent the edges are, the more obvious it is. So F32 delta x is 0.005. Okay, so this is blending, and this is no blending. Hold on, what if we make the window smaller? To there it is. Now you can see it. The window needs to be pretty small though, yeah, you can see the dithering there. Okay, let's turn blending back on. Make the window smaller again. Okay, I think this does look like it's supposed to look. Although you can kind of still see, like when it's very small, you can still see that problem. Yeah, like here. Like what if you like make it super small? Well, I mean, at this point, I guess the... Okay, so at this point, the source art is... Well, it's larger than the pixel grid, to be sure, but it's like the closer the source art gets to the pixel grid, the more obvious that problem is. Like if we turn off blending and take a look at what it looks like then, one window is that small. Let's see. It actually help, I wonder. I mean, yeah, it's obvious. I mean, I guess we could just create the window at that size. Width is 100 and height is 1000. Oh my god. Well, probably more than 100 because that's pretty close to pixel 1:1. 200. Is that really 200? ID. Let's do 400. Okay, something like this. What is that? Oh, why is it like that? Okay, that is weird. It's not what it's supposed to be. Okay, so that's what that looks like. Did just the one pixel blend, does it actually help? Like if you blend right on the edge. Let's see. Okay, well, like when you launch it, it seems kind of blurry. Like instead of being all crooked, it seems blurry instead. Is that just floating point getting in the way of... Okay, well... It's kind of hard to tell. I mean, you can still see it. You can still see the dithering there. It's moving left and right slowly like that. Well, you can still see it here as well. Okay, I think it's a little muted, but still visible. Okay, let's just take a bunch of... take one capture, let's say. Okay, well, I can see the vertical blend. Let's... hold on. Can we... okay, let's see. Q capture frame 100 and capture me like 10 frames. You can, maximum of 10 frames. Okay. Let's just make it so the update happens every time. Let's say here. Like that. It's 10 frames. Okay, launch. There's the frames. It's the first one. It's the second one after that. Huh. The third one. Is it the case that it's just... Okay, and now we are in a situation where we are seeing some blending, and the blending looks correct. Well, I mean, in terms of blend factors anyway, gamma, but the blending looks like what's been programmed. But it just happens so that this is the frame, as in like essentially the only frame. Well, not the only frame, but this is the first frame where the position worked out to be not aligned with the pixel grid. So in the previous frames it was aligned. On this frame it's not aligned. It was aligned here. And then it's back to alignment. And back to alignment. 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 Okay. I see. Interesting. So when the source pixels are somewhat close to, well, not super close, but you know, somewhat small, I guess, then doing this kind of blend, I mean, it will soften the impact of jittering, but you can still see the jittering. What happened here? What did Clang format shit itself again? Yes? No, not Clang format, Clang D. The language servers are a joke. Let's go back to full screen. And the defaults, I guess. Okay. So the source here is much smaller than the factor by which it's stretched out. So that like the source pixels are very large on the image. And here we can see how we're not doing bilinear blending, we're doing this custom blending. And it's the movement is smooth visually. Of course, if we turn off blending, it'll still be smooth. Because the jittering is only happening in very few places. Yeah, so that's still smooth. I can slow it down even more. Okay, and now we turn on blending. Okay, well, it looks a little smoother, I think. But you really need to look. Or maybe you don't. Maybe when there's more things moving around, it's a little more obvious. I don't know. But the point is that this is doing what it's supposed to be doing. So let's remove that. Let's remove this. But there is that region of art where the pixels are too large for bilinear, but too small for this kind of blend. And in that region, it'll still be... yeah, it'll still be kind of questionable doing this. Well, so what are the to-dos? Pass in those things, do the gamma thing. Well, I need to, yeah. Alright, what did we do here? We implemented full screen, that's good. Do that anyway. Remove trailing white spaces, yeah, that's also good. Clamping the textures now. This is really not necessary anymore. This was for debugging. Yeah. Yeah, well, it's minus 10 plus 2.5 and 0. Delta, is this remove trailing white space? Yeah, that's fine. That's here. Input's different now. We need to pass that in, and the pixel shade is different now. All right. Compile. Run. Yeah. Okay. Well, custom blend. Custom blend. Oh my god, what, oh. Did they? No, it's fine. I thought they removed something. No, I didn't. Okay. Well, that's all for today. Thanks everyone.